doing? Are you guys stressed?
Yes.
Yeah.
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 So, yeah, I know final exam is cumulative, right, with Dr. Stoy. So, my best advice would be to go over your exam 1, 2, 3 material, and those contain the bulk content of what's going to show up on the final exam. So, if you have any specific questions, like a concept that you want to go over, we can do that. Or otherwise, I can just, I bring my first 3 exams so I can look at them and, just tell you like, oh, you got to know this and that. And if we want to go over specific concepts, we can do that. So whatever you want to do. Is there a specific concept that you want to go over?
Do you happen to know what percentage of each chapter is going to be on the exam?
It varies from year to year, but the cumulative final is 200 points worth, and I believe it'll be 120 points come from the first 3 exams, and 80 points come from your final exam content. So maybe like 33%. I'm not exactly sure, but other years, Dr. Stoy can do like 100 points from 100 points from the first 3 cumulative, and the other 100 points from your final exam material, like gas laws and what else? Spin as well as yeah, chapter 10 is what he will focus on.
So I have sorry, continue.
Yes, no, go ahead. No, go ahead.
So like, does he give us a study guide for that, or is it like all our own preparation and studying from like what we learned throughout the course?
Yes, what you learn throughout the course. So if you ask him like, what should we focus on? Like he would say, go look at your, like the first 3 exams and the concept of it. So which exam would you like to start on? You want me to begin from exam 1?
Yeah, exam 1.
Okay. So exam 1. So you have to know your sig figs. There are 2 different rules, right? For subtraction, addition, and for multiplication and division. For addition and subtraction, you want to make sure you want to be counting the decimal places. And for subtraction, for multiplication and division, you want to look at your significant figures. And on the exam, if he says report the answer with correct sig fig, like how he would write correct sig figs in bold and in capital letters, you have to worry about sig figs for those problems. For other problems, you don't have to worry about it. So you have to know that you got to know what extensive, intensive property is. So intensive property doesn't depend on the amount of a substance. Like for example, intensive property would be temperature, because it doesn't depend on the amount, right? No matter if you're weighing 50 mil of water or 500 mil of water, it'll still tell you the same temperature. And not extensive property is the one that depends on the amount that you have, like your mass. So yes, that's your intensive and extensive property. And please feel free to interrupt me along the way if you have a question about what I explain, okay? And you have to be able to look at the periodic table, and let's see if we have one. Let me go grab the periodic table. So group 1 is called alkali metals, and these metals lose electrons to form +1 charges like Li plus, Na plus, K plus, Rb plus, Cs plus. We usually ignore these because they're radioactive. And for the group 2, we call it alkaline earth metals. And these are your D block elements, right? Transition metals, which appear in your, I believe, exam 3, right? And when you're writing out your electronic configuration in exam 2 too. So this is your group 3. And we don't usually like name group 3 anything in particular. This is your group 4, group 5, and for group 6, we call it chalcogens, right? Chalcogens, chalcogens, and group 7 is our halogens, and this is our noble gases. So that's like your periodic table, like the group number, and you got to know how to convert degree Celsius to Kelvin, and that's very important because you will be using Kelvin temperature scale for your gas laws, like Boyle's law, Charles' law, and all that. So knowing how to convert is very important. So just for a review, I'm sure you guys know this. So Kelvin equals degree Celsius plus 273.15 degrees Celsius. If you want to convert a degree Celsius into Kelvin, you will add 273.15 to your degree Celsius. And if you want degree Celsius, you subtract 273.15 from your Kelvin scale. So you have when you do dimensional analysis, you have to know the conversions, right? I believe Dr. Stoy would go like, okay, let's say meter is the base, and you go from milli, micro, nano. Milli would be 10 to the negative 3, milli, micro would be 10 to the negative 6, nano would be 10 to the negative 9. Would you guys like me to do a problem regarding doing the conversion?
Yes, please.
Okay, so let's do this problem. I don't know if you guys will be able to see. So the question asks you to, can you guys see, or is it too far?
Yeah, I can see.
Oh, okay, good. So he wants you to convert 2 micrometers to centimeter, and he'll give you. So this is multiple choice. So he'll give you 5 answers, and A is 2 times 10 to the 3. B is 2 times 10 to the negative 3. C is 2 times 10 to the negative 4. This is negative 5, sorry. Okay, so you want to convert micrometer into centimeter. When I said milli, micro, nano, I didn't mention centimeter, but centimeter is 10 to the negative 2, okay? So how, like the way Dr. Stoy would convert this would be this way. So you have 2 micrometer, right? Micrometer. And when I said milli, micro, nano, like we want to go in by 3, like 10 to the negative 3, 10 to the negative 3. I think that'll be easier. So 2 micrometer, if I have 2 micrometer, I'm going to convert this into millimeter first. So it'll be, where would you put your millimeter? Would you put it in the numerator or in the denominator?
Numerator.
Exactly, because we want to cancel micrometer. So I will put micrometer here and millimeter here. And 1 millimeter is 1,000 micrometer. So that's something that we have to know. And now this goes away, right? Like dimensional analysis works with what cancels. So now we have millimeter, but that's not what we want. We want centimeter. So I would convert millimeter into meter. So it'll be, I'll put meter up here, millimeter down here. So 1 meter is 1,000 millimeter, and millimeter goes away. But this is not what we want. We want centimeter. So what is the relationship between a meter and a centimeter? Does anyone know?
Can you repeat that?
What's the relationship between or what's the relation between a meter and centimeter? Like how many
Isn't it
centimeter?
1,000 or is it
A
100?
Actually,
100.
yeah, it's actually 100. You know, like I realized that this is something that students get confused about. But so remember that 1 meter has 100 centimeter. Okay, so it'll be I will put meter here because I want it to go away and I want centimeter. So I will put centimeter up here. And we said 1 meter is 100 centimeter. Now we can cancel this. So we'll be left with our centimeter. And when you do the math in your calculator, you will get 2 times 10 to the negative 4 centimeter. And so C would be your correct answer. Does that make sense?
Yeah.
Yes.
Okay. So yeah, so this is like your, sample dimensional analysis problem. So that's that. And then you'll have to know how to write formula. Like if he gives you like 2 elements. Oh, this element, let's say he'll tell you something like, what is the formula of the compound formed between strontium ions and nitrogen ions? So you have to be able to like how to say write a molecular formula in the correct way. So do you want to try that? Or are you guys good with that?
Can we try that?
Right?
Okay. Sorry, what? Sage, did you have a question?
No, I just said the same as her. Could we try it?
Okay, that's good. So may I erase this?
Yes.
Okay.
Or
Yeah.
everybody
Yeah.
else.
Okay. Feel free to take a screenshot of the board or anything. So I said strontium ions, right? So he tells you strontium, okay, strontium ions, and then nitrogen ions. Nitrogen ions. So can you guys tell me where the charge of what the charge of strontium ion would be? It depends on the group that I just went over. If it's on group 1, it'll be 1 plus. Group 2, it'll be 2 plus. Group 3, it'll be 3 plus. And group 4 can vary. And group 5 is usually 3 minus. And group 6, the chalcogens, like, the one where oxygen sulfide, they can be 2 minus. And group 7 is your halogens, and it'll be -1, right? Because F minus, Cl minus, Br minus. And group 8, it doesn't have, it's, it is noble gas, it won't participate. So can you tell me what strontium ion would look like the oxidation state of it?
Is it 2 plus?
Perfect, that's good. So it's 2 plus, Sr 2 plus. And what about nitrogen ions?
3 minus.
Exactly, that's correct. So and 3 minus. Okay, so I don't know if you remember this, but when you're trying to make a compound, Dr. Sai would use this like soupy soup, do the soupy soup. So you have Sr2 plus and you have N3 minus. Soupy soup basically means like you put this here and then you put this there. So it'll be Sr3 and 2. And he gives us answer choices like A is SRN, B is SR3 and 2, C SR2 and 3, D SRN2, E SRN3, and we know they're all wrong except B, which is SR3 and 2. Does that make sense?
Yes.
Okay. So, yep, that's one. That's your, like writing out the formula thing. And then, what else? You have to know how to do, how to calculate empirical formula. That's one thing. And I don't know if he will, he could ask you a problem like this. Like, can you see this? Like this box. Do you want to go over that or are you comfortable with that? It's like, it's 1 point each, but it can be like 11 points or something. You want to go through that? like this box, writing up
Go through it, please.
neutrons. Huh?
Could you go through it, please, then?
Yeah, okay. So why don't we try this example, okay? So so he will ask you what the number of protons are. Sometimes he'll give you. So in this problem, he doesn't tell you what the number of protons are. And then there's number of neutrons. And he gives you all of that, 28, 35, and 33. And then number of electrons. So he gives you number of electrons for this, but not this, not this. Okay. +6, question mark, and +2. Okay, so before we proceed this, I'll tell you some key concepts, okay? So number of protons mean your atomic number. Let's say if someone asks you, hey, what's the number of protons for chlorine? And it'll always be 35 because chlorine has its own unique atomic number, which is 35. It doesn't change. Number of protons equals the atomic number. And number of neutrons is your like your mass number, which is this, minus your proton number. That's your neutrons because protons and neutrons make up the mass of the atom, right? And it's in the middle, the center of the atom. So that's your neutron number. And number of electrons is how many electrons you have. I mean, that's self-explanatory, but number of protons and number of electrons are equal only when when your element is neutral. Let's say I'm talking about magnesium atom. So the number of protons for magnesium would be 12, right? Because the atomic number of magnesium is 12. And when we're just looking at Mg, which is neutral, no charge, nothing. So the number of electrons of magnesium would also be 12. So you can say in that case, oh, the number of electrons and number of protons for magnesium, they're the same, 12. But what's the ion? What's the charge of the magnesium that usually forms when it forms ions? Like the oxidation state?
+2.
Exactly. Yeah. So it'll be +2. Why? Because it's in group 2, alkaline earth metals, they lose 2 electrons to form Mg2+. That's good. So what would the number of electrons be here if it becomes +2?
10.
Exactly, right? Because +2 means when we see a positive thing, I think we sometimes have this tendency to, add things. Like, oh, the normal number of protons and number of electrons is 12. Now that it's +2, we're going to add it. No, that's wrong. Because number of electrons +2 means that you have deficient. Your electrons are like, you're like 2 electrons short. So that's why you subtract it and you get that. So that's good. So it'll be 10 for this. And let's say for like oxygen, the protons, number of protons would be 8, and number of electrons for an neutral oxygen atom would be 8 too. But when it becomes O2 minus, like in an oxide, it'll be 10, right? Because it gains 2 electrons to become this 2 minus. So, yeah, why don't we do this together? So we're looking at chromium, and it tells you the charge here, which is +6, and the symbol, not symbol, sorry, the mass number of chromium is 52. Can you tell me the number of protons for chromium?
24.
What would you look at? Exactly. How do you know that? Because yeah, sorry. Go ahead.
I do.
How do you know?
Well, I take 28, I add 2 to get 30, and then I subtract that from the 52, and
Yeah,
then
that's
add 2
one way to
additional.
go. Yep, that's perfect. You can do that. Or you can go to your periodic table and then look at chromium and then you can just look at it. Oh, it's chromium is 24, right? Like the atomic number of chromium is 24 because number of protons and atomic number are the same. But that's good. So that'll be 24. And what about electrons? How would you do that?
You subtract 6 from the protons.
Right, that's true. Okay, so you would do 24 minus 6, and that'll be 18, and your net charge is plus 6. Does that make sense? Right, like when you do it like step by step, I think it'll be easier. So, can someone tell me what the number of protons for Cu2 plus is?
29.
Exactly, that's correct, 29. Okay, so you can go to the periodic table and then look at where copper is here, 29, or you can just subtract the number of neutrons from the mass, right? So that's good. And what about the number of electrons? I'm sure you guys know this by now. Sorry, what?
27.
Exactly 27, right? You just take away the 2, so that's good. But what about the net charge? I think this should be very, very straightforward because he gives you
Plus 2.
exactly, right? That'll be plus 2. And here, this is a different one. We don't know the first two, so why don't we try it? How would you get that number of protons? It's like different from the other two.
You could add the net charge and the number of electrons.
Exactly. So this will be 26, right? That's perfect. Good. And now we know all of it. So all we have to like do is come up with like this. So what first of all, what element is it?
Fe, iron.
Exactly.
Iron.
Because yes, that's correct. So it's Fe. And for the net charge, you would do plus 2 because it's already given to us. And then how would you find the mass number?
Add protons and neutrons.
Exactly. When you add 26 and 33, you get 59. So I hope this makes sense. And it's not bad, right? Like you can do it, right?
Yeah.
So okay. So that's that.
I
And
have
then yes, go
my
ahead.
advisement meeting, so I have to leave, but thank you for
Oh,
this.
you're welcome. Yeah. Take
Bye.
care. Bye. Yeah. And then you have to know you'll have to be able to name the compounds. Like if he gives you like uh Al2SO3 3 minus sorry, Al2SO3 like bracket 3. I just write it Al2SO3 3. You have to be able to like name it. Can someone tell me what the name of it is?
Is it
I'm sorry.
aluminum?
Sulfate, sulfite, sulfate,
Is it sulfate or sulfite?
sulfate, fight,
That
fight, fight,
yes,
fight.
it's actually sulfite, right? Because SO3. So for a problem like this, what I like to do is just break the compound apart to Al, and then we know Al is in group 3, so it'll form Al3 plus, right? So it is Al3 plus, and then SO3. What's the charge?
2 minus.
Exactly. SO3 2 minus. So SO3 2 minus is your sulfite, ITE, ite. Okay. And SO4 2 minus is your sulfate, SULFATE, sulfate. So this will be aluminum sulfite. Does that make sense?
Yeah.
Yes.
Okay. So what about this? What about S2 minus? How would you call this?
A sulfur ion?
Um, yeah, that's one way to go, right? But sulfur ion, but there's a name for it. Just like how you would name sulfate. There's a name
Oh,
for it.
like,
Is it sulfurous?
oh, damn.
Uh, Sage, what did you say?
Said sulfite because it's still too
Yeah,
much.
yeah. So how do you spell it? Sorry,
Uh,
SUL.
huh? What?
Like, how would you spell it? Did you say it's sulfite, the same thing, like with ITE?
Yeah.
Actually, it's IDE, sulfide ion.
Oh,
Remember, like chloride, sulfide,
okay.
IDE. Okay, so be careful about that. Sulfide, IDE, IDE. And this is ITE, ITE. So there's the difference for that. So why don't I give you the general formula for all that, right? So like I make a note about it. So uh like I'll tell you how to like write what ions to form, you know, because sometimes you have to change the ions to an acid. So the general trend would be the ide ions, like I mentioned, S2 minus sulfide or like chloride ions. The IDE ions form hydroic acid. Are you familiar with that? Like
Yeah.
ide ions form hydroic acids. An example would be chloride ion, right? Chloride ions form hydrochloric acid. And what about this H2S? It's an acid. So how would you call this acid? What's the name
Isn't
of
it
it?
like hydrosulfuric acid?
Yeah, it's very close. That's correct. Hydrosulfuric acid. And why? Because when you like break it apart, S2 minus is your here as sulfide, right? IDI. So ide ions form hydroic acid. So it'll be hydrosulfuric acid. That's good. So another one that you want to know is eight ions. ATE8. Eight ions form ic acid. Okay, eight ions form ic acid. ATE8 ions form IC acid. An example would be, I'll give you another example. Um, Here, PO4 3 minus. What's the name of this ion?
Phosphate.
Phosphate, right? ATE phosphate. So if I tell you that this forms an acid, what would you name this?
Hydrophosphoric.
Phosphic?
Um, so the formula says eight ions form ic acid, right?
Yes.
So it is phosphate, so it'll form phosphoric acid, right? We don't put the hydro because we put the hydro for what when it ends with IDE. So something that like makes me remember is when we have IDE, which has this D in it, it has this hydro in front, like hydro. The hydro also has the D, hydro. So ide ions from hydroic acids, but eight ions, they're just ic. Does that make sense?
Yes.
Okay, eight ions from ic acid. And the last one is ite, right? When you just said sulfite, SULFITE, sulfite. Ite ions form us acids, us acids. So why don't we go with that example? SO3, 2 minus. What's the name of this ion again?
Sulfite.
Sulfite, right? With ITE. So if it forms acid H2SO3, what's the name of that acid be?
Sulfurous acid.
Exactly, that's right. So sulfurous acid, right? Sulfurous, ROUS, rust acids. So do you guys like, is it good? Like those three like formula, like
Yeah, I get it now.
yeah.
Thank you.
Okay, okay. So that's something that you want to know, and then you have to be able to balance your equations. So um, when you do your balancing the equations, my suggestion would be if you're balancing hydrocarbon compounds, meaning a compound that has carbon and hydrogen, or sometimes it can have oxygen, right? When you're dealing with, like, let's say sugar, oxidation of sugar, what you want to do is you want to start balancing carbon first and then hydrogen, and you want to make sure you balance your oxygen last. If you balance your oxygen the first thing, it can be hard to work with. So good tip for balancing is to um yeah, you can still see, hopefully. So let's say you have A plus B going to let's say A let's say AD plus BC equal has DC plus AB. What you want to do, this is just an example, I just made that up. What you want to do is you want to like split two sides, write A, B, C, D, A, B, C, D. Does that make sense? Like just to keep track of how many like the numbers that you keep adding as you balance. Like, do you guys see what I'm saying, or you want me to give you an example?
I see what you mean.
Okay, good. So that's, you have to know balance your equation. And yep, you in your exam, I'm sure. Do you guys get back your old exams or no? You have your old exams with you?
I have some of mine,
Okay,
except for the
that's
third.
good.
Back the last one.
Oh, okay. Do you want me to send my third exam to you guys?
Yes, please.
Okay. So yeah, I can. Yeah, I will send that to you guys. I don't know. So why don't you? No, I'll actually write down your email, I guess. Yeah. So can you tell me your, both of you? You know what? I'll tell you my email, and can you guys like email me to remind? Like my email is short. It's just K M. I'll write it out here. KMYAT at mail.niagara.edu. So it's just KMYAT. Is it good?
I got it.
So KMYAT at mail.niagara.edu. And then I can send you my exam 3. So so you'll have to know how to balance equation, and then you'll have to know how to do dimensional analysis, right? Converting, let's say, grams grams of one thing into moles. So that's that's one that's one thing, right? Like grams to moles, and then in other problems you have to convert grams to moles, moles to grams. I'm not. I like. Do you know what I'm saying? Like it's like the back problem, like the near the end of your exam one, where you have to find your um, empirical formula. You know what I'm saying?
Yeah.
Okay, and that's the thing. And when you find empirical formula, you will find what you want to end up with is your moles. And once you get the moles of all your atom, like forming that compound, you wanna write, you wanna do something like let's say your compound consists of K, Cr, and O, and let's say you have like moles like 0.25 mole of K and 0.30 mole of chromium, or you have like 0.15 mole of oxygen. You wanna Do you remember this thing? Like where you do this sign? Like you wanna divide it with the least number, which would be in this case 0.15, 0.15, 0.15, and then you will get your like your whole number. If it's not whole number, you will multiply like with 2 or
Oh yeah,
3.
I remember this. I remember this.
Yeah, that's good. That's good. So when you multiply it all, you will have, if you don't have a whole number, you can keep multiplying. But the rule is once you multiply this thing with 5, you have to make sure you multiply all of it with 5. Okay. And then um, the you can round up or round down, but it has to be plus or minus 0.1. You remember that? Like it has to, if you have 4.9, you can round it up to 5. If you have 4.8, you can round it up to 5 because it has to be plus or minus 1. Again, if it is 5.1, you can round it down to 5. If it is 5.2, you can round it up to, you can round it down to 5. Does that make sense?
Yeah, that makes sense.
Yeah.
Okay, okay. So, so yeah, that's one thing. And know how to calculate your percent yield. And I'm gonna give you the formula for it. So I hope I can erase this. So the formula for percent yield is your actual value over theoretical value times 100. Sometimes you can write actual as your experimental, right? Like what you do in lab or what you get, the over theoretical, meaning the one that you calculated out using dimensional analysis. Good? Or you
Yep.
have questions about it? Okay, so yeah, we're done with exam 1. That takes a while. And you guys want to do exam 2 or exam 3?
Exam 2. I got exam 3, I think. Pretty good.
Yeah,
I
I
don't know
feel like
about
a lot of you guys do well on exam 3, which is great. That's awesome. So your exam 2, okay, you have to know your strong acids and strong bases, right? That's so important. How many strong acids are there?
7.
Exactly. Can you tell me what they are?
Ooh. I know, isn't it like hydro? I don't even know. Sorry.
Okay, that's fine. So I wanna make sure I'm telling you the right thing, although I know what they are. Well, okay. It's your hydrochloric acid, hydrobromic acid, hydroiodic acid, sulfuric acid, and nitric acid. And the other two is uh um wait, wait, I'm sorry. Yeah, sulfuric acid, nitric acid, and your HCl, HBr, HI, and HClO4 and HClO3. Yes, I'm pretty sure that's the one. Wait, I wanna see what I have written down just to make sure. Mm, sorry, I'm sorry. It's not HClO3. It's H3PO4, which is your phosphoric acid. So let me like repeat it from the start. There are 7 strong acids. They are HCl, HBr, HI, H2SO4, HNO3, H3PO4, and HClO4. Okay? So like, does that make sense? Because I know in my notes, I actually took notes that Dr. Stoy say that these are the 7 strong acids. But in the book, you will see HClO3 listed as the strong acid. But we go with what he says. Is it familiar? Or I'm just not sure if if he has like if he says something different to you guys. What do you know as your 7 strong acids?
He said the same to us.
Okay, that's good. So yeah, you have to know your strong acids and your strong bases. So strong bases are basically your OH minus, right? Hydroxides, all group 1 hydroxides, which will include your LiOH, NaOH, KOH, RbOH, CSOH, and your heavy group 2 metal hydroxides. And heavy starts from calcium. So CaOH2, SrOH2, BaOH2. Your 2 light ones, which is your Be and Mg, like the first 2, is not your BeOH2 and MgOH2. They're not your strong bases. So it starts from Ca to Ba. And like I mentioned before, we ignore the last two just because they're radioactive and we don't work with them. So those are your strong acids, strong bases, and another thing you have to know. Oh wow, you have to know your solubility rules. So are you guys familiar with solubility rules, or do you want me to like go over it, like the rules?
Could you go over solubility? Because like
Yes, yes. So yeah, it's solubility rule. I would say is like kind of strict. Like you have to know it to be able to answer the question. Wow. I don't know. I saw it, but I don't know where it went. Sorry, guys. Okay. So your first solubility rules is actually, although we say it's solubility rules, it's like solubility rules and insolubility rules. Okay. Would it be easier for me to read it out or write it down? Is it okay for me to read it out? I think it'll be quicker. Like, what do you guys prefer?
You can read it.
Okay.
yeah,
So,
I'm fine with reading it.
okay, perfect. So I'll start with the solubility rules. Okay. So all nitrates are soluble. That's a rule. All nitrates are soluble. Whatever that you have, like let's say you combine I I don't know, like Ag with your NO3, it'll be soluble. Once you see a compound where its anions is nitrate, and the formula of nitrate is NO3. What's the charge? You know the charge?
Is it 2 minus?
No, it's actually 1 minus. NO3 minus 1. And that is your nitrate. And yeah, so NO3 1 minus, NO3 minus, it is your nitrate, and all nitrates are soluble. And another rule is all acetates are soluble. And acetates, you can, I don't know how you write acetate, but like I write it as CH3, COO minus ions, right? All acetates are soluble, but sometimes you can see Dr. Story saying like instead of CH3, COO minus, you can also write C2, H3, O2 minus. To me, this comes easier, but you can choose whichever way you wanna write. But the point is all acetates are soluble. So we're done with two rules. All nitrates are soluble, all acetates are soluble. And the third rule is all chlorides, bromides, iodides are soluble, except there are exceptions, except with three atoms, and that is except with Ag plus ion, your silver ion Ag plus, and your Hg2 2 plus, Hg2 2 plus. We write it like this. Let's see, Hg2 2 plus. That's your mercury, and then lead 2 plus, which is your Pb 2 plus. So Ag plus, Hg2 2 plus, Pb 2 plus. So all chlorides, bromides, and iodides are soluble except when they are paired with them. Okay, so that's your third solubility rule. And your fourth solubility rule and your last solubility rule is about sulfates. SO4 2 minus, right? Sulfate. All sulfates are soluble except Sr2 plus, which is in your group 2, Ba2 plus, Hg2 2 plus, and Pb2 plus. So I'll repeat it one more time. All sulfates are soluble except Sr2 plus, Ba2 plus, Hg2 2 plus, and Pb2 plus. So yeah, that's that. And now we have our two insolubility rules. So are you guys okay with the first four solubility rules? Or do you have any questions?
No.
Okay. So all sulfides, 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 right? S2 minus and hydroxides, OH minus, are insoluble except when they're paired with ammonium ion, which is NH4 plus, and then alkali metal cations. Alkali metal cations are your group 1 metal cations, which are Li plus, Na plus, K plus, Rb plus, Cs plus, right? All of them, one, two, three, four, five, yeah, all five of them. And your heavy group 2 metals again. So your heavy group 2 metals are Ca2 plus, Sr2 plus, Ca2 plus. So, yep. So I'll repeat that one more time. All sulfides, S2 minus, and hydroxides are insoluble except NH4 plus, alkali metal cations, Ca2 plus, Sr2 plus, and Ba2 plus. And your last insolubility rule is about carbonates and phosphates. Carbonates are CO3 2 minus, right? And phosphates are PO4 3 minus. All carbonates and phosphates are insoluble except with ammonium ion again, NH4 plus, and the alkali metal cations, which is your five Li plus, Na plus, K plus, Rb plus, and Cs plus. So good, good with solubility and insolubility rules. Like I know it's a lot, like you have to really memorize it to be able to apply it on your exam. Like, and I'm sure you've seen that with your exam too. Like he could ask you like, okay, circle each soluble ionic compound. So it'll be like like he'll give you like, like these compounds, and you have to like know the exact thing, exact metals to be able to circle it. Does that make sense?
Yes.
Okay. And you have to know your oxidizing agent and reducing agent. So let me, like tell you the definition of oxidizing agent and reducing agent. So oxidizing agent oxidizes others, right? Which is why its name is oxidizing agent. But it itself is reduced. And in the same way, reducing agent reduces other, but itself is oxidized. And to describe the process of oxidation and reduction, there's this, like easy thing like mnemonic or whatever, that's like Ulrich or Lioger. So Lioger is focusing on your electrons. Loss of electrons is oxidation, and gain of electrons is reduction. Or like Ulrich is like oxidation is loss, and reduction is gain, like Rick. And then you have to know how to like write out your oxidation state if you're given like let's say sulfuric acid, let's say H2SO4, and he can ask you like, okay, what's the oxidation state of sulfur? Like, you know what I'm talking about? Like he could pinpoint the atom that he wants to know and ask you
Yeah.
about that. Okay, yeah, so you should know that. And then of course, I feel like chapter exam 2 has a lot of math, so I'll tell you like different math that you have to know. We only have 6 more minutes, so we don't really have time to go over, problems. So you'll have to know how to calculate molarity, right? If you're given moles and uh, okay, what's molarity, the big M made up of? It's a
Moles per
big,
liter.
perfect, moles per liter. So once you see that big M, you can just translate that into moles per liter. That's good. So that's your moles per liter. You have to know how to calculate molarity when you're given moles and liter, and yeah. So when you're given a gram, you convert your grams into moles by using your molar mass. And Ionic equation, writing Ionic equation. So basically, to write Ionic equation, you start out with precipitation reactions, right? Precipitation reactions are where you add two soluble compounds to make one insoluble compound product as your product, and another soluble compound A good example would be like an example would a reaction that gives us BaSO4. We know BaSO4 is insoluble, and then if you're like, okay, why is it insoluble? We can go back to the insolubility rules, right? Because BaSO4 sulfates. All sulfates are soluble except with this, and that, and Ba is one of them. So BaSO4 is insoluble. And I'm sure like you may have seen it with, in your lab, like BaSO4 is a white solid, insoluble. So we can form BaSO4 by adding two soluble salts, like let's say BaNO3, 2, because barium nitrate is soluble because all nitrates are soluble. And we can also form a compound with sulfate, which is soluble. Like let's use something from group one, like Na2SO4. So if you mix those two, you'll get BaSO4 and NaNO3. So that's your precipitation reaction. And you write out your uh, another equation where you split the compound apart. If you're working with BaNO3 2, you will split it into Ba2 plus NO3 minus, and you will keep doing that except with the insoluble one, because if it is insoluble, you don't touch it. You just leave it as solid, and then you will cancel the ions that show on both sides. There's a name for those type of ions. Can you tell me which cancel out in the ionic equation? Starts with an S.
Spectator ions.
Perfect, spectator ions. So once you cancel out the spectator ions, you'll have your ionic equation, and that's how you would write your ionic equations. And another thing that you have to know is neutralization reaction. Let's say he will give you like, oh, okay, so we have this acid. He will give you the mole of that acid and volume of that acid. What you want to do is change the acid into, find the moles of that acid, and then derive the moles of the H plus ion by using mole ratio, right? Let's say if we're working with H2SO4, there is two H plus ion in every one molecule of H2SO4. You do your mole ratio of that, and once you get the H plus ion, you do this. Remember, like you would do the soup thing, like here, like you would do this like soup thing. So that will be your um, H plus moles of H plus equals moles of OH minus. And then you'll get your moles of OH minus, and you want to find the moles of the base by you doing your mole ratio. And then depending on what he's asking you for, he could ask you for molarity or volume. You'll find your molarity or volume. Okay. And you'll have to know the heat delta H Hass's law. So the simplest way to put Hass's law is to say that if you want to go to, if you want to make, let's say you want to make A to B, so the route that you take to go to B can be this, or you can do this. Either way, let's say 1, 2, 3. 1 has to equal 2 plus 3. Okay, so that's the idea. So it doesn't matter which route you take, it has to add up to the same energy. And then, excuse me, please know how to do coffee cup calorimeter problems and bomb problems, because yeah, so the formula that we use for coffee cup calorimeter is m equal no, not m, q equal mc delta t. You can always use that whenever coffee cup problems arise. And for um oh, but it's 2 right now, but because like we took like 3 or 4 minutes, going from one to another, I can give you guys 5 more minutes. Are you guys okay with that?
Yeah.
Yeah.
Okay. So yeah, we'll end at 2:05. So 16 is the bomb problem in my test. So bomb problem, there's no specific formula for it. You have to work with dimensional analysis. Let's say he gives you the calorimeter of your bomb yeah, specific, not specific, heat capacity of your bomb calorimeter, you will write Q over delta T. And this is something that we derive as we're working through it, but bomb calorimeter problems doesn't have, like a set formula like coffee cup. So you have to work with your um, units like along the way. And another thing that you have to know, oh wow, I skipped this part. So you have to know how to write your electronic configuration, right? Are you guys comfortable with that?
Yeah.
Yeah, I
Okay,
know how to
so
do that.
that's good. So and you have to know how to do what's this problem? The three guys, Polly, Afal, and Hans rule. Are you guys comfortable with that, or do you think you need like a little brush up of it, or you know?
Can you brush up, please?
Okay, brush up. Okay, so Hans rule states that you have to fill. Why don't I go to that page so that it's easier? Well, for some reason, I don't have that page anymore, but it's okay. I know. So Hans rule states that you want to fill out that a good example would be this. So uh, if you have this, you want to fill it out like this. You don't want to pair it like this first. Does that make sense? You know what I'm saying, right?
Yeah.
If you have like a orbital, like this is a p orbital, and if you are just trying to fill two electrons, you want to uh, minimize repulsion so that you put the other electron in the separate orbital rather than pairing it, right? So that's your Hans rule. And alpha is you want to fill out the lowest orbital first. So this is our p, and let's say we start with our s. So this is like 1s, 2s, 2p. This is 1s, 2s, 2p. We want to fill out the 1s orbital first, right? And then only after that we fill out 2s. We don't want to skip to 2p. So alpha is basically telling you that. And polys is very easy one. You don't want to pair electrons in the like same or like the same orientation. You want to pair it like this instead of like this. Does that make sense?
Yes.
Okay. Okay. So that yeah, those are the three rules for that. And yeah, I would say that's about it. But oh, you can also look at the 3D pictures of your, 1S, 2P, or 3D there. Like there's just one shape for S, the the circle one, and for two you have sorry P you have three figures. For D you have like five figures, and pretty sure I like you're aware of that, right? Like this. Like this is your d orbitals, right? So those are those are some of the things. So we're out of time, and since you guys said that you guys are okay with exam three, I'll just send you guys your exam three, okay? And email me, and that's about it.